This video is Heterogeneous Mixtures by Mr. Thiel. Okay, we'll start off by talking about the two basic types of mixtures. Just a review. There are two different types of mixtures. We have the first type, which are heterogeneous mixtures, and the second, which are homogeneous mixtures. Heterogeneous mixtures are those mixtures that have particles that are unevenly distributed throughout the substance. So in one place, one part of a particular heterogeneous mixture, you may have more of one type of particle than in another. And if you have two heterogeneous mixtures that have the same components, one of them may have different percentages of those components than the other. So this is the hetero has a root that means different, and so heterogeneous mixtures are those mixtures that have unevenly or differently distributed particles. Homogeneous mixtures, on the other hand, describe mixtures that have an even distribution of particles. So the particles are evenly distributed all throughout the mixture. At any one location of the mixture, you'll have the same percentage of particles as any other location within the mixture. Another word for homogeneous mixtures is solutions. The homogeneous mixtures are often called solutions. In fact, we probably use the term solution more than homogeneous mixture. Okay, this video is primarily about heterogeneous mixtures. So first, again, we'll start off by defining the heterogeneous mixture. So a heterogeneous mixture, and I've already described it a little bit, is a mixture that has an uneven distribution of particles. And that's our basic definition of a heterogeneous mixture. So the great classic example of a heterogeneous mixture is the pizza. So pizza is a great example. So here I've got a slice of pizza, and this is a great example. It's a very commonly used example of a heterogeneous mixture. It's something we can all understand, and most of us even like quite a bit. Now, we'll talk about heterogeneous mixtures maybe in two different but kind of related ways here. The first thing that I'll talk about is that heterogeneous mixtures may have different regions. So when we look at a pizza, we can see that there are different regions, and this is something that homogeneous mixtures don't have. If there are regions in a particular mixture, it is heterogeneous. So when we look at a pizza, we'll see that there are different regions. Like, for example, we have the crust region. So that's the part of the pizza that has the crust. And then we have our sauce region. So this is the part of the pizza that has the sauce. So we're looking at like different layers here, different levels within a pizza. And then the next region we would say is the cheese region, maybe. So we've got the crust region, the sauce region, the cheese region, and the last region on our pizza is the toppings region. So we have these four different basic regions within our pizza. When you have this, it is a heterogeneous mixture. Homogeneous mixtures do not have different regions. They're the same all the way through by definition. So we go back to the whole pizza here, but what we can say is that when we have different regions, we have a heterogeneous mixture by definition, and when we're looking at a particular substance. So pizza is very clearly has these different regions that we can separate. Now, the next way that we'll talk about heterogeneous mixtures is not in terms of regions or different layers, as I've done here on this particular slide. On the next slide, though, we'll look at a pizza again, and we'll have that definition of heterogeneous again. Well, not on this slide. So, but here's our pizza. So we've got a pizza here. And now what we'll do is we'll look at different samples from different locations in the pizza. So let's say you're eating the pizza, right? So you eat the pizza, then you take your first bite. There's bite number 1. And you take a second bite. There's bite number 2. And you take a third bite. There's bite number 3. So we've got, with our first bite, now there's 3 bites right there. And what we have here then is we have 3 different samples of the particular pizza that come from different locations in the pizza. Our 3 bites are 3 different samples. So our first bite, when we look at our first bite, we have pepperoni in our first bite. but that's it. That's our only topping that's in our first bite of the pizza. Now our second bite of the pizza has pepperoni, it's got some sausage, it's got peppers, and it's got black olives. So there is our second sample. Our second bite has got 4 different toppings in it, and that's different from our first sample, which only had the one topping in it, the pepperoni. Now we look at our third bite. Third bite of pizza here has green peppers again, and we've got some sausage again, and we've got some mushrooms again. Or not again, actually, that's the first time we've had a bite of mushrooms here. If it was my pizza, I'd remove the mushrooms, but that's the first bite of mushrooms that we had in our 3 samples, our 3 bites. And then we've got some pepperoni again. So we had pepperoni in every bite. We had sausage and peppers in 2 of the bites, but we only had black olives in our second sample, our second bite, and we only had mushrooms in our third bite. And so this is another indication that we're dealing with a heterogeneous mixture. Heterogeneous mixtures, this is only possible in heterogeneous mixtures where you have samples from different places that actually have different components in them. So our first bite only had 1 topping, the second bite had 4 toppings, the third bite had 4 toppings also, but those toppings were different than the toppings in the second bite. And that would be impossible in a homogeneous mixture. Every bite would be exactly the same in terms of its components. But in a heterogeneous mixture, this is a characteristic of a heterogeneous mixture, that different locations within the mixture have different components. So we have bite 1, bite 2, and bite 3 there. Now, so what we can say is that if we have different samples with different components, and in this case the samples are our bites, the 3 bites of the pizza, there are 3 samples of the pizza, and if we have different samples with different components, then by definition, again, we have a heterogeneous mixture. Okay, now what we're going to do is we're going to look at 2 special types of heterogeneous mixture. So these are just 2 of the special types of heterogeneous mixture, and we've discussed them in class. So the first one is called a suspension, and the second one is called a colloid. So first we'll look at a suspension. So, by definition, a suspension is a heterogeneous mixture that is in fluid form, so we're looking at mostly liquids. It could be in a gas, theoretically as well, but a heterogeneous mixture in fluid form with particles that are large enough to settle out. And that's what we would call a suspension. So for our suspension, we are going to look at a heterogeneous mixture that has shown up already a couple of times, and that heterogeneous mixture is some muddy water. Alright, so if we look at muddy water, and then we look at the particles of muddy water, if we're able to see them, what we would see is this mixture of water molecules, the H2O Mickey Mouse ear-looking molecules there, and then our mud particle, which is wouldn't technically be mud, but it for our purposes that's good enough. So we've got this mixture of water and mud. Now muddy water is definitely a suspension type of mixture. It's a heterogeneous mixture where you've got more than one, you've got this sort of uneven distribution of particles, and they are in suspension because eventually that mud will settle out. So when that mud does settle out, we get something like this right here. So we've got our muddy water here again, but after some period of time, it may only be a few minutes or maybe a couple of hours or something, but we clearly have a different looking situation here now visually with the naked eye without even having to look at a microscope or anything like that. But if we were able to see the particles of the substance, now we have this clear differentiation between the top of the muddy water and the bottom. So if we look at the top of the muddy water, what we see is mostly water molecules now and a few little mud particles interspersed within the mostly water situation. And when we look at the bottom, where most of that mud has settled out, what we see is mostly mud and a little bit of water down there. And so we have these 2 different regions now, or these 2 different samples from different locations within the same mixture, and that makes it a heterogeneous mixture. But specifically it's a suspension where those particles that were part of that heterogeneous mixture in this fluid matrix have settled out over time. All right, so the next type of mixture we'll look at is the colloid. And the colloid is probably the most difficult, I think, to understand of all the mixtures that we'll talk about, because it's sort of an in-between type of mixture. So, and even by definition, it is considered technically a heterogeneous mixture that contains particles that are intermediate in size between the particles you find in suspensions and the particles that you find in solutions. And these particles are small enough that they will not settle out. So they're intermediate in size, but they will not settle out. So they're not as big as the particles in a suspension, but they're definitely bigger than particles you would find in a solution, but they're not so big that they're going to settle out, that they're going to settle down to the bottom like the mud in the muddy water. Another example, actually, of let me go back. I'm going to go back to the previous slide just for a minute. Another example of a suspension that is more common maybe than muddy water that you would encounter is something like chocolate milk. If you make homemade chocolate milk with powder, I prefer to use the powder rather than the syrup. You may feel otherwise. But if you make chocolate milk with the powder, if you let that sit for a little while, and with chocolate milk it might take a little longer, maybe a couple hours, but if it were to sit, that chocolate would settle out. So that is another example, just another example of a suspension. Also, a snow globe is an example of a suspension that is often used. It's used in our textbook. So anyway, we'll go back to our colloid. Whoops. Go back to the colloid. Where are we at here? Okay, so colloids have this sort of long definition, and they are sort of hard to understand. They're these in-between substances. There's a couple things to point out here. Colloids can't normally be filtered. So in any sort of normal filtration process, you're not going to get these particles that are mixed up in the colloid. You're not going to get them to be removed by filtration, by filtering them through some sort of normal filter, like a coffee filter or something like that. And so this makes them like solutions. You can't filter the coffee in your coffee, can't filter that out, or tea in your tea, that can't be filtered out either. So colloids are like solutions in this way. They're unlike solutions, though, in that they scatter light. If you shine light on a colloid, the light is scattered, and you can kind of see the light if you're shining light through a colloid, or if you're looking at light, if you're looking through a colloid at light, that light will appear maybe kind of foggy or scattered. So we look at, and this is unlike solutions. Solutions don't do this with light. So some examples of colloids, we've got milk is an example, shaving cream, and actually lots of common household products and food products fall in this category. We've got Jello. Jello is a colloid, and fog is a colloid. It's a colloid that where you have water particles that are suspended in the air. And mayonnaise is another example. Gel-like substances tend to be colloids. Okay, so what we'll look at next is we'll just look at this one characteristic of colloids. It's often used to identify colloids. That is the fact that they will scatter light. So we'll look at, for example, maybe some milk. Now, if you did this with whole milk, you wouldn't really see the effect. What we're really talking about here is skim milk. Maybe even just some drops of skim milk in water could change the effect of water, which is a pure substance that's not going to scatter light. It will change that to a different situation. So we'll take a little bit of milk, drop it in some water, and you can see that turns that water into a colloid. And it's milk that's the colloid. So we have our little glass of milk here, and we get a flashlight, and if we were to turn on the flashlight and shine it through this, or any other, it could be gelatin, it could be doing this through fog, like a laser that you might shoot through fog or something like that. We turn on that light, and what you're going to see is you're going to see a beam. You'll see the beam passing through the colloid that you may not see before or after the colloid. And this is something that's very characteristic of colloids and can often be used to identify colloids if it's not clear that that's what you have. So that's it for our discussion of heterogeneous mixtures. Next, if I have time, I will make a video about homogeneous mixtures or solutions.